Alrighty, we have some new friends.
Hey, it's always good to have friends.
It is great to
Welcome.
have some new friends. Friends, can you please give us a moment to, go ahead and give us an idea of what it is that you do for AWS and what we're going to be talking about? You mentioned is data-driven sustainability. Is that correct?
Yes. Hey everyone, I'm Janan Yanachandran. I'm a principal solution architect at AWS focusing on data, AI, ML, and sustainability. Sandeep?
Hey, good afternoon, good morning, good afternoon, good evening, folks. I'm Sandeep. I'm based out of Minneapolis in Minnesota. I'm a senior partner solutions architect for sustainability. Super excited to be part of this conversation today.
Yeah, so I think the other note is for everybody out there, we're also joining everybody from lots of different places around the globe too, kind of commensurate with where our operations are as well. So welcome to both of you for joining Kyle and I today here. We're pretty excited here to get started.
Thank you.
Now we're talking about data-driven sustainability. Now, what does that even mean?
So if you look at sustainability data is the core of any sustainability efforts, right? The sustainability data particularly focus on collecting, processing, and analyzing information across environmental, social, and economic impact of all the human activities on the planet. So this data can be used to address large sustainability problems like climate change or carbon emission reduction and other initiatives. So the reason that data is important, we need to measure the baseline of where we are today and monitor and manage the change towards our sustainability goals.
So we need to, if you will, collect the information to be able to take action and know what to do next. You have to kind of know where you are before you can correct what you're doing, essentially. All right.
So why is looking at the sustainability data? So you're mentioning, you don't know where you're at until you figure that out, and then you get an idea of where you need to go. How is this data helping create these different, sustainability practices?
So in order to collect this data, there are some challenges, right? So four key challenges. If you look at, and I can divide that into data acquisition, data organization, transparency, as well as standardization. So if you look at the acquisition side, right, there are like disparate data systems. So if you look at social, economical, environmental, and economic sources, we have disparate data system where we are collecting the data from, along with different data acquisition cycle, right? If, the timeline of collecting this data across these sources are different. And then the other challenge is like we are collecting data at different formats, right? And then as a customer, as an enterprise, in order to do a sustainability transformation, the data what we use along with the data what our partner use is important as well. And the second challenge is like, okay, all right, so I collect all this data. How do I really organize this data so that I can make it meaningful for my sustainability initiative? So I have to make sure that I store data in a standard format across the board. I need to ensure that my data is quality because your sustainability transformation is as good as the quality of your data. And then you have to make sure that the data is reliable and transparent, right? Make sure that we have the right emission factoring for accounting perspective. And then we have to have the consistent methodologies for across the board for us to compare ourselves or benchmark ourselves with the competitors and peers. And then finally, we need data standardization across the board. Make sure that right now that one of the challenges like lack of data standards across the board. So we have to make sure that there's a standardization across the board.
So is there any way how do we do some of this across in order to make sure that we acquire the data, organize it, and make sure that it's reliable? Do we have any particular ways that we can tell people about that, how we do that?
Yeah, Art, I can briefly talk about it. And let me screen share and show a few sources. So I want to show you what AWS provides from a dataset standpoint. I want to show a few examples so that it makes it more clear. So let me share my screen and let's get started here. So the first thing I want to flag is this initiative from Amazon called Amazon Sustainability Data Initiative. This is a set of public data sets from across the board. Take weather, climate, water, socioeconomic factors. A lot of these data sets are available on AWS via this ASDI initiative. And the advantage is you can bring all these data sets to your application very easily, very quickly. So, instance, if I just click on one of the data sets here, let's say like the global surface summary of the day. So in this instance, like if I want to bring this data set to my workload, we already have an S3 bucket name, region, how to access this data. So this is one mechanism where a lot of these open data sets, you want to incorporate it. It's fairly straightforward to do it. Another good source to get sustainability data is our AWS Data Exchange. So within this, there's a lot of third-party data that's available. So if I scroll down and click on ESG and sustainability, you can just see the breadth of data sets that's available. So Jana touched on, environmental, social, economic, and even governance data sets. A lot of those are available via Data Exchange, which you can just bring in. And then the last, go ahead.
Yeah, sorry to interrupt you. So I think one really important thing that you're showing here is that we're actually providing, I think just to be really transparent to everybody, we're providing everyone access to large data sets to help people make decisions as well, to give people access to this. So this isn't, and I think sometimes when we talk about data acquisition or the data itself, a lot of people think about, oh, what data is Amazon doing? But this is really, we're giving people the opportunity. In this case, you showed some data from NOAA, the National Oceanic and Administration, but I can't remember their complete acronym here.
Data sets from NASA. So there's a lot of academic research that happens, and they're all in public domain. So often the challenge is how do you get that data set into your workload?
Yeah, I think that that's an awesome part about what we're doing here is the ability to access that data so that people can act on it, so that we're all operating off of the same data sets as well. I think it's a really great way to get started. And I think I cut you off midstream with the third item here, so maybe we should get back to it.
The third part I want to show is on the solution side of things. So if you look on another link, and we'll post all these links on the chat window if you want to explore. So we have the AWS Solutions Library, and as you can see, there's multiple options available here, right? You could explore AWS services, but also AWS made solutions. There's also partner solutions, and lastly, guidance. So these are architectural diagrams and sample executable code you can look into. And I want to bring folks' attention to this sustainability solutions library. So if you click on sustainability, there's couple use cases, and this is ever growing. This is just a snapshot. We are continuously adding more and more use cases and solutions. But one piece that I want to show everyone and bring some visibility here is if you click on carbon accounting, there's a lot of movement in the market right now with folks needing emissions management and accounting platforms. So here you can see some of our partner solutions. But then if you want to build your own carbon accounting platform, we just launched a week and a half back, we launched this guidance for sustainability insights framework. So this is a set of architecture around all the concepts that Jana mentioned, right? Like the challenges with data. This makes it a lot more easier. So you have a lot of architecture around how do you bring some of those together? How do you design solutions that does some of these calculations? But also we have a GitHub library. There's a lot of executable code. So if you are someone building a solution around carbon accounting, anything to do with carbon accounting, please take a look at this. This is going to accelerate, just the development time. Some of the undifferentiated stuff we've already built, so you could build on top of it. So I encourage folks to check this out.
Yeah, and I want to give just a commercial for a topic, Kyle, we're going to be doing a little bit later on is regarding the Sustainability Insights Framework. We're also going to talk to a customer of AWS who is actually taking advantage of the Sustainability Insights Framework a little bit later on today, and how they've both used this to help their customers, and how you can either use the Sustainability Insights Framework yourself, or use their framework, or use what they have built on that as well.
Awesome.
Yeah.
So what is so you mentioned the AWS Data Exchange. Now, what are some of the, I guess you could say, patterns that we've seen to, look at sustainability? And I believe you were mentioning one of the problems that can be challenging is the data acquisition, and that's where the data exchange can help customers acquire data. But also, what about the reliability of that data?
Yeah, so Kyle, I mean, to answer all of this, how about I show you a live demonstration? Do you want to see a live?
I would love to see a live demonstration.
So we are
No
gonna.
one loves a demo more than Kyle and I.
That's very
Okay, so
true.
we're gonna get our hands dirty. We're gonna see some console and some code. Are you ready for it?
Yes, if there's pop-up pictures too, that's even a bonus.
Okay, so let me share my screen. Let's go through a real demonstration, right? We can talk about this, but let's go through a real demonstration and see how these data sets can be used. So I'm going to share my screen again.
Sounds good.
And so the example today I'm going to walk you through is lake algae detection. So what this is like, this is Lake St. Clair. You can see Michigan, United States on your left, and Ontario, Canada on the south. So algae growth in lake, this happens because of nutrient overloading. So whenever there's excess nutrients in water, it leads to toxic algae blooms. And this is a skin irritant. It's a public health concern. But also if you're a manufacturing plant or a drinking water facility, and this is your source water, having lake algae could upset your processes downstream. So today we're going to try to see how do we use AI and some of the satellite imagery from Amazon Sustainability Data Initiative to try and predict lake algae formation. So I want to give you an overview of the workload, like what we're going to walk through in the demo. So there's going to be 4 steps, and I'm going to break down these 4 steps for you. First, we're going to start by getting that satellite imagery data. So before, this is going to be a challenging part. Like, how do I even go and get satellite data? But with the ASDI, it makes it very straightforward. We have, a satellite called Sentinel-2. This is from the European Space Agency. And this particular satellite has 13 different bands. And for today's example, we're going to use B8, B4, and B3. So near infrared, red, and green. And the reason we are doing this is, image speaks 1,000 words, right? So you can see on your left, it's just a natural color, but then on your right is the color infrared. The difference between these 2 images, chlorophyll with the color infrared, it really pops. So this is a way for us to quickly identify where's vegetation, and then you can see like urban areas or sand. It shows up in a muted color. So step 2 is to do some image processing. We're going to do some image processing in the cloud. Step 3 is to build tiles. So often these satellite images, they cover vast distance, and we want to do the AI inference just on areas of interest. So step 3, we're going to we're going to cut these satellite imagery into equal sizes. And then the last step, we are going to try to see if AI can detect lake algae formation. So examples on your left, you can see how unhealthy lake looks like in that false color image. And then on your right, it's a healthy lake where we have a clean lake surrounded by a lot of vegetation. So this is what we're going to try. How do we do the detection using AI? I want to please stop me at any point if you have any questions.
Well, I'm just impressed, first of all, because one, you didn't need to, launch a satellite from your backyard to acquire these images. And so you're able to obtain this data to understand, if there was invasive species of algae in a lake. And actually, I know Lake Tahoe, there's a huge thing about invasive species of algae or any sorts. It's the Keep Tahoe Blue, and there's a lot of things that go into place to protect the lake. And it seems like these are types of technologies that organizations that are looking to keep lakes clean could leverage, but also understand where they're at and their efforts, kind of like a compare and contrast.
That's exactly right. And just how fast it is to bring these data sets and start using them, that's the added benefit. And I encourage folks to play around with ASDI. There's so many data sets out there. Satellite imagery is just one of them. But now if you want to put satellite imagery and add weather data on top of that, it's again fairly straightforward to do it. So the architecture that I'm showing here, so let me break down this architecture here. So there's 2 parts to it. One is on everything you see on your left. This is identity and access. And I'm not going to unpack this. This is outside the scope of today. But think about it as the big picture here is we're going to have an API gateway, an API front door to our application, and then a mechanism where users can authenticate themselves using Amazon Cognito. So this is slightly outside the scope of today's discussion, but what we'll focus on is the actual workload. So I'm using a lot of, go ahead. Okay. So I'm going to be using microservices. So all the 4 steps that you saw before are broken down into 4 steps here and house them in Lambda functions. So Lambda is our serverless event-driven compute service. I just need to focus on the code. I can have a bunch of code and hit execute and it'll run. I don't have to worry about provisioning servers and managing the infrastructure. Lambda takes care of all of that. And then another piece that I want to highlight here is Amazon recognition. So this is our pre-trained computer vision model. Let me show you recognition here real quick. So it's our pre-trained computer vision model. You can see like examples like text detection or celebrity recognition. It can do without need for any training. But for today's demo, we're going to use a feature called custom labels. So with custom labels, what you can do is you can tune Amazon recognition to detect objects and images that are specific to your business needs. So in this instance, we can tune recognitions to detect lake algae. And then the last piece you're going to see in this architecture is everything's wrapped in AWS step functions. And what this is our serverless workflow orchestration service. So after each step is over, I don't need to go and click step 2, step 3, step 4. AWS step functions automatically takes care of it. It completely orchestrates it. If there's any error handling, AWS step functions take care of that. So this is a good mechanism where if you're using microservices and instead of having a monolithic application, you break down your service and you can wrap the whole thing in AWS step function. Any questions so far?
No, so far I think it's pretty cool here, what we've put up here. So using kind of AWS Lambda to kind of help us detect the algae here in this lake. It's pretty cool.
Awesome. So let's get into it. Let's actually run this in real time.
Yeah.
And see how it works. So for today, we'll use Lake Okeechobee as an example. So Lake Okeechobee is in Florida, in the state of Florida, southern United States. This is the largest freshwater lake in the state of Florida, and they constantly have algae issues. So let's try to see, go see if we can detect lake algae in Okeechobee. So step 1, I'm going to run this Lambda function where all it's going to do is get those satellite bands from the 8, 4, and 3 from ASDI and put it into Amazon S3. So let's go into console. So I'm going to hit test and I'm going to walk you through what exactly is happening. So in Lambda, you can see my code and I don't have to worry about provisioning infrastructure. All of this is taken care of with Lambda. This is an example of Sentinel-2 dataset. So if you go into the dataset, it's telling you how to use that data, right? So the resource name is available, the region is available, the CLI access if we need it is available. So I use this to incorporate that ARN into my code. And what this function is doing is getting that satellite image and then putting it in my local S3 bucket. So I'm just going to refresh my local S3 bucket to see if files are popping up. So the band 08 has just been copied, and it's around 120 megabytes. So we're going to have 2 more bands that's going to show up. So so 8 showed up, 4 showed up, and then 1 more band. So that's step 1. We got our image. Step 2, we're going to do some image processing. So now that we have the bands, the raw bands, the 8, 4, and 2, I believe, we want to create that false color image so that the chlorophyll really pops. So let's go back and create that false color image. And here I'm doing it manually, but as I said, when it's wrapped in a step function, these things are going to happen automatically. So let me run the code and then walk you through what's happening. So I'm going to show a few features of AWS Lambda. So in this instance, if I go into the configuration tab, you can see that I've allocated a good amount of memory and timeout for this particular Lambda function. The reason is memory is the principal way developers can add more compute power to Lambda functions. So the higher the memory, the more compute resources are going to be assigned for Lambda functions. So that's one piece. The timeout, Lambda can run up to 15 minutes, but here I'm putting a timeout of 1 minute 30 seconds. So if my workload did not end before 1 minute 30, something's wrong, and I don't want to waste compute resources by continuing to run it. So I provided a timeout of 1 minute 30. If you go
Well,
to
it's important we do that, right, when you look at your compute resources, right? Because compute resources, utilization of resources costs money for whomever is using them, right? So we want to make sure that we're efficient in all aspects of the work that we do here, right? Accessing the content, doing the image recognition. So
absolutely, well said. I mean, we have, as architects, that's where we have the sustainability pillar of the well-architected framework, and you're going to hear a lot of that about the how to architect in the cloud using principles of sustainability well-architected. You're going to see a lot of that today. And so this is a good point. We only want to use the resource that we really need. So by using Lambda, by using recognition, by using a lot of these fully managed services, everything that you see today, it's going to scale automatically. I don't have to worry. I'm not over provisioning in the cloud. So I've incorporated as much best practice as possible to minimize resources. Yeah.
And I think what we could do here is we could link to the different services that are being utilized in this architecture. So we could, look at what it is that we built based on these technologies. But let's go ahead and see, you mentioned you're bringing in data, you used code from, open source, and we're looking at a lake that the largest freshwater lake in Florida. Let's go ahead and look at the outcome or what this workload is doing for us right now.
Yeah, so the false color image just got pushed into S3. Let's actually take a look at what that false color image is. So if I just open this image, and let me show you the actual resolution so you can get an appreciation of how big this is. So
there's
this
my house.
was just done in real time. And let me move over to the lake. So you can actually see early signs of algae growth happening. So it's a massive satellite image, but you can see the early signs of algae growth happening. And this is what we're going to do in our next step, right? Because this image is so wide, we're going to break it up into equal squares. And again, we're going to use the Lambda functions to do that processing for us. And then the last step is, can AI tell me that there is some algae growth happening? So that's what we're going to do in our next step.
And like all great baking shows, do we have a pre-baked example that has already been in the oven that we can show our audience?
Yeah. So let me. I do. So I just have to run one Lambda function real quick, and it doesn't need to execute in full time. So let's go to the very last set, which is to actually detect a lake algae. So I'm going to be using the service called Amazon Recognition. And here we talked about, custom labels. So if you go, I just want to quickly show like how straightforward it was to run and get custom labels. So here I use the same Lambda functions to generate test images to train it. So if you look, these are examples where algae was detected, and I used around 28 images to train it. And then lastly, examples of healthy lake have around 36 images that was used to train. So let's actually see if we are able to detect. So I'm going to hit the last function. I'm going to hit test. So here it says, if you read the code, algae was detected, and it gives me a confidence level. So what that means is when recognition runs, it returns a confidence level. So anywhere from 0 to 100. So if I'm sending a picture of a dog and a cat, and for cat it comes back as 90, and for a dog it comes back as 20, I'm fairly confident that it's going to be a cat. So that's what here it has a really high confidence that the image that we just submitted, it was able to detect algae. So the whole process could be automated, and then downstream it could send an email, or it could trigger something else as downstream for someone to take action.
And we have a question from our friends in the audience. How do we estimate compute time if it needs more processing based on the complexity of an image?
Yeah, and Jana, please feel free to chip in here too. So one way to do would be to look at the compute optimizer as a resource. Another way would be, I believe, like I've seen a GitHub resource where it helps you to tune Lambda functions to make sure that you are running at that optima. So it runs different types of Lambda functions based on your workload and helps you zero in on the ideal memory that you can allocate to it. So I will move into chat and drop a link to that GitHub resource.
Yeah, in addition to this, you can also leverage our container orchestration framework like ECS and ECS on Fargate to automatically scale these large scale workloads.
Yeah.
Awesome. Well, hey,
Okay.
Sandeep, Jana, it was awesome and great to see this awesome technology and also the different data exchange. And I like the fact that I don't need to launch a satellite from my backyard to get satellite imagery to detect algae. But I'm really looking forward to seeing what different groups do with this type of data that they have access to, along with the different artificial intelligence and machine learning type of services that AWS has to help become more sustainable, or also understand the problem much better than what they may have originally hypothesized.
Absolutely, Kyle. And I mean, even in the example that you just saw, instead of lake algae, like imagine an agriculture application where I'm using satellite imagery to detect the yield. Whatever I showed you, a lot of that code can be reused. And this is the benefit of the cloud, right? I'm not again starting from scratch. I could use 90% of what I just showed you, train another model to detect for my agricultural use case and get that going. And so again, highly recommend folks to go take a look at ASDI and see what you can do with it. Check out Data Exchange, see what you can do with it. Play with the SIF framework. Yeah, I mean, these are tools that we can use today to start developing solutions to solve sustainability challenges.
Awesome. Well, thank you so much for your time. And stay tuned, because we have an awesome topic of conversation coming up again. These are all awesome. You're going to hear, that's going to be the theme of Kyle today, is everything is awesome.
The chat, I'll be on LinkedIn and check out on the chat. I'll spend some time on the chat answering some questions.
Wonderful. Thank you so much.
Thank you. Thanks for both of you for joining us today.
Thank you.
All right.
Have a good day, folks.
Don't go anywhere. Stay tuned.